Okay, we're doing estimation here. So we're rounding to one significant figure, which basically means make each number as simple as we can. 3.93 becomes 4, 393 becomes 400, 0.546 becomes 0.5, 220 becomes 200. Cubing it inside the roots. Okay. What we can do now is we could work these numbers out, or we could do a little trick and actually cancel out those by dividing top and bottom by 100. Lots of ways of doing this question. I'm doing it without the whole idea of estimating is to do it without a calculator. So even though it is a calculator question, I'm trying to do as much as I can without. So 0.5 times 2 becomes 1. 4 times 4 becomes 16. I'm still cubing that. This is where it gets a little bit tricky. 16 cubed is going to be quite a large number. What I could actually do is, actually let's first of all write it like this, is I could take the square root first and then cube it. That becomes 4 cubed, which is manageable because that is 64. Probably at this point you would just go straight from here to 64 using your calculator, but I just thought I'd do it non-calculator. Calculate the error in an estimated answer as a percentage of the exact answer. So that's going to be, I'm trying to find the error as a percentage of the exact. So that's it as a fraction. To get it as a percentage, I just times it by 100. So that's how we can calculate the percentage error. So I just need to work out the true value now. So let's have a go at that. It's the square roots, and then I've got a bracket and a closed bracket. I'm going to put the fraction in, 3.93. Good stuff. 0.546 times 220. Just remember we're cubing it, so raising it to the power of 3. That gives us 46.105. So it's going to be 64 minus 46.105. That will give us the error. And then we're going to divide by this 46.105 because that's the exact answer. And we're going to times that by 100. I can use the answer button to keep it exact. And I get 38.811. So roughly 38.8%. Okay, so quite a significant percentage error, and the key thing I think is that we're cubing something. So when you cube something, the errors just get really big straight away because, you know, our rounding doesn't seem too bad. But yeah, I know we're square rooting as well actually, which makes the error a bit less, but the cubing does have an impact.